In this video, we're going to be talking about solving quadratic equations by graphing. Now, when we solve quadratic equations by graphing, the first step is to write the equation in standard form. So our ax squared plus bx plus c. We want the ax squared to be positive. So if that means you have to move everything to the other side, do that. The second step is going to be to graph the related function. So we're going to use our graphing calculator to do that. Third step is to find the x-intercepts, if any. Now our x-intercepts are going to be where the function crosses the x-axis. Now the solutions, or the roots, of our ax squared plus bx plus c equals 0 are the intercepts of the graph. So how do you know the number of solutions that the quadratic equation is going to have? Well, there are three types of solutions. Two real solutions, one real solution, or no real solutions. When there are two real solutions, our graph crosses the axis, the x-axis, 2 times. When we have one real solution, our graph simply touches the x-axis. And when there are no real solutions, the graph does not touch or cross the x-axis. Let's do some examples where we solve by graphing. So in this first example, we have x squared plus 2x equals 3. So we want to find our a value, which is x squared, and it's already positive where it's at. So we want to move everything over to it. So here we have our a, our b, and our c. So we're going to move our c over by subtracting 3 from both sides. That is going to give us x squared plus 2x minus 3. Notice our a, our b, and our c values. From here, we're going to plug this into our graphing calculator. So we're going to y equals, and we're going to plug in x squared plus 2x minus 3 and hit graph. And we see that it's going to cross in 2 places. So to calculate that, we're going to go to second trace, which is our calculate feature, and we're looking for the zeros. So we'll do our left side first. So we're going to be on the left-hand side of that intersection. Notice that the blinking cursor is to the left of my star. Now it's asking me to go to the right bound of that. So I'm going to go to the right. Now again, notice that the blinking cursor is now to the right of my star. I hit enter, and now my star should sit between those two lines, which it does. Then I'll hit enter again, and it's going to give me an answer of -3. So that's going to be my first solution. Then we're going to do it again. We're going to calculate the 0, but this time we're going to go over to the other side. So we're going to go to our left bound. Notice that it's on the left side of my star. Then I'm going to go over to the right bound, and we see that again it's on the right-hand side of my star, and hit enter, and my star is sitting between those two lines. I'll hit enter and get a value of 1. So here we see that our solution would be x equals -3 and x equals 1. In part B, we have x squared minus 8x equals -16. So we'll locate our a value, which is positive. So we're going to move our c value over to the side with the a squared already on it, or the x squared already on it, rather. So we're going to add 16 to both sides, which is going to give us y equals x squared minus 8x plus 16. So we still have our a, b, and c values. So we're going to plug that into our calculator. So we're going to plug in x squared minus 8x plus 16. And then we're going to graph it. Well, it looks like it's only going to have one solution. It appears it's only touching. So we're going to calculate our 0. And we want to be on the left-hand side. There's my cursor. So I'm on the left-hand side. I'm going to arrow over to the right-hand side, and notice that my star is now sitting between that, which is what we want. We're going to hit enter and get a value of -3.99999. So that's actually really close to a 4. So here we have a value of x equals 4. Now in part C, notice that our a squared is negative. Well, we don't want it to be negative. So we're going to move our a over. So we're going to add the x squared to both sides. And that's going to give us that 0 equals the x squared plus 2x plus 4. So we're going to go ahead and graph this. So let's move our graph over. So we'll go to our y equals, and we'll plug in x squared plus 2x plus 4 and hit graph. And this one is hovering, and so we know that that's going to be no real solution. And so we can write down no real solution, which is sometimes abbreviated as NRS. Let's look at an example here. We have a graph of f of x equals x minus 3 times the quantity x squared minus x minus 2. So in this case, it's not necessarily a quadratic equation. Notice that it's got a cubic look to it. And we want to find the zeros of this graph. So how do I know how many zeros there are? Well, how many times does it cross the x-axis? 3 times. So I'm going to have 3 different zeros. I'm going to have one at -1 because that's where it's crossing. I'm going to have a 0 at 2 because that's another intersection point. And I'm going to have a value at 3 because that is our final intersection point of our graph. And so those would be the zeros of this function. And that's how we'd find them using the graph. So when we're graphing, using the graphing calculator, let's write down what our steps might be. So here it says the graph of f of x equals x squared plus 4x plus 1 is shown, and it says to approximate the zeros. Now notice that our intersection points aren't at whole numbers, and that's why it's asking us to approximate. So what are the steps that we would do? Well, first, for approximating, we would graph. So we'd go to y equals and graph. So here we're going to go to y equals, and we're going to type in our equation, x squared plus 4x plus 1, and we're going to hit graph. Then we're going to calculate the zeros. And we do that by pushing second, trace, and choosing the second option. From there, we have to find our left bounds and our right bounds as we did before. So that's where we go to the left side of our intersection point, then to the right side of our intersection point, and that's going to give us an estimate of about -3.73. Doing it again for our other intersection point, which looks pretty close to 0. So second, trace, option number 2. So we'll go to the left-hand side, and then we'll come over to the right-hand side, which is going to give us a -0.28. So probably round that to an 8 based off of the number that we had. And those are going to be our approximated solutions to our graph.